So, good afternoon. I hope you had a good lunch. So, we will try to keep a presentation, let's say, short and concise. My name is Socaciu Claudiu. I'm with Progress Technologies for more than 15 years now. And what we'll show today and discuss, it's a proof of concept on how to embed solar technology for querying your records faster and let's say improve the performance of the database itself. This is the agenda for today. We will do also a live session. I will show you code, what I've installed, how it works, and so on. So we will have also technical presentation and pieces of code here. And for the rest, you will see that I'm more a technical guy and not a specialist in PowerPoint, but you will coping with me on that, okay? So first of all, why this approach, solar? Over the years, in my past experience with customers and what we developed for them, we always arrived in a point that we have performance issues. No matter what we did, no matter what we improved the queries, at a certain moment in time, there was nothing to do. So what we actually did is try to offload that from the Progress DB, and we search for alternatives, and one of the alternatives that it's actually long time on the market, it's solar. So solar is basically a search server. What you do, it's fetch data to the servers, fetch records, and then he will get you back the results quite fast via querying. So this is actually what we will showing today, is how to install a solar server, how to configure it a little bit, what is a schema that you will be using for maintaining your data in solar, and after that we will go with updating records in solar and querying the search server. As you see here, we will have, I've used two things. I have the Progress DB installed on a Windows machine. Why? Because I'm using an OpenEdge free version, trial version, so the DB has to stay on Windows, because that's the only trial that Progress provides. And for the solar server, I use the Windows subsystem for Linux. Because it's, let's say, all this solar stuff and Tomcat stuff, it's usually better on Linux. And production-wise, you want to go with Linux. So first, we have these two prerequisites, Windows VSL2 installed and Java installed on VSL. Because I'm using solar version 7.3, I've used Java 11, it's an old version, but that's another topic. Installation is very simple. As you see here, we just downloaded the archive from the internet. You unpack it, and then you can start right away the solar. I will just explain a little bit why there are two parameters here: the force and minus V, because this is VSL2. It's not a really Linux machine, so it's something for, let's say, recently developed by Windows. It's not very stable. So you had to use the force qualifier to be started. And you can see that I'm root on this machine, and that it's not advisable to start the solar server as root, but for development purpose will do. And the V qualifier is for verbose output, so you can see all this nice logging here. And after you start it, of course, you want to know, is it running or not? So first thing you can do is check the status. the command is solar status. You will see that it will say on the PID ID of the process and what port is running. Of course, if this is successful, you can also check the status via localhost. So basically, if it started, this is your endpoint on the localhost, where you will see that this is installed. And basically, here, this is a management console. I can show you this live. I have it open here. This is the management console where you can see all the stuff happening on your solar instances. For this demo and session, I prepared one core, the global search core, where I have indexed some data in order to be able to show you how to query and what to do here. So just a little bit of explanation. Once you install the solar, you have to configure it. Basically, you can configure it from here, or you can do it via, let's say, via Unix and Linux. You have the green button, Add Core. Basically, that is what I did to add this global search core. What I did is provide the name of the core. That is, let's say, global search, instance dir, again, global search, and you have two very important files, the solar config.xml file and the schema file. I will briefly explain you the schema file because this is important in order to understand for you how this schema is related to your database that you want to be, let's say, indexing via this, via the solar. So I will open my Ubuntu box. I have it here, install it on solar and on the server. Resources, I think, okay. Global search, you will have here the conf and you will have the .schema XML. So I will just copy this. And try to open it. And discuss with you a little bit about the schema. As you can see here, what I did here is actually modify a little bit the schema. So the schema is a flat document file. You can find example how to modify it. But we will be working on Sports 2000. So Sports 2000, it's like a business database. You have customers, you have items, you have orders. It's something that it's very common in the OpenEdge landscape to have such an application and like database. So first, in order to be able to retrieve your records faster, and basically if you want to search by an address, by a phone number, by, I don't know, company ID, VAT number, you will need some links between entities. So first of all, I've defined parent ID, entity. I've defined an active or inactive because records over the time can be obsolete. So then you might want to just leave them behind. Location is just if you want to use geocoding or something like that, you can have that. So basically, in that, I was thinking to add more, like if you have a database that uses like partitions or something like that in order to divide customers, or do you have like a logical key on the tables to divide between branches and so on. So you can put here something like that in order to be able to do that. For this demo, I thought that just keep it simple, don't do that thing with partitioning. Okay, So parent ID in this case is the unique key of the parent. So if we will be indexing an order on an item or something like that, we will be putting like the parent ID of the order for an item, and for an order you will be putting the parent ID of a customer. Why? If you find an item, you can, let's say, go very fast on the hierarchy and find your customer if you want that. Okay. Entity, of course, speaks for itself. Entity can be customer, can be order, can be item, can be an address, and so on. Can be a sales representative and so on in this case. So basically, this is the schema that I loaded on my core. And it's important to understand and think of your schema when you create this for your database, because actually this is the common link between your database and the Solr search engine. What else I want to, let's say, point here is that once you do this, you will need a specially crafted XML file to be sent to update the records. Otherwise, you will get a 400 bad request. So once you do this, you have to know what type of XML, how it is structured to send that to your Solr. And then we will go back to the presentation. So as I showed you the global search, the config, and coming back to the link and the schema, this is a piece of code that will make one moment. I will show you. Maybe something like this. Okay, so the XML example, as you see, it has the ID, it has the entity, active filter, valid start, some text. Text is very important. Why? Because actually the text is what we will be searching on this proof of concept, and the parent ID, of course. And org is that what I told you about to logically separate between branches, customers, or if you have tenancy, you can use like a tenant ID there or something like that. So the dataset definition, what we do with this dataset, basically this is a generic dataset that it's matching the schema file that I loaded in the global search core. And basically with this, when you have a record that is updated, created or deleted, you can update your data into the Solr engine. So this is for fetching data to the Solr engine in order to be indexed. This is the part. And I will show you how do we do this now. So I have here index customer entity. Basically, this is a piece of code that is used to index a customer record when it's changed. You create your data set. There is some basic error handling that I will not bother you with. We create just the header. As you can see here, we have an update node, an add node, and in the doc node you have all the stuff. And very important is the commit node, that it's empty. The commit node will instruct the Solr server to commit this into the database. It's important to keep in mind, and when going in production about this commit, you can do multiple commits. Basically, you can have batch sizes of records and commit only once. But this is depending on your application and on your landscape. So basically here to be simple, I've committed every record at a time, one at a time. So More or less, this is the data set used to produce an XML like this. After we create the unique keys and the records, I've choose to let's say combine address, city, country into one indexable field, just to have more sense. The contact, customer name, phone, postal code, email address, and so on. And basically, what I did is create a data file from it and use the right XML provided by progress function to create that XML file. Okay, what I'm doing with this XML file, you will see here, I have right customer index, and what you see here is that when one of the fields that I want to index is changed, I use this function to do an index customer entity. There are multiple ways of doing it. If you want to do it in production, you have to have this, let's say, parameterizable. You can use config files and so on. This is for, let's say, proof of concept only, so this is much or less hard-coded. You don't do it like this in production, please. Okay. Back to the index customer entity. You will see the last line of code. Post solar data with curl. Basically, what we are doing here is using curl to post the data to the solar server. I will just open this. Why curl? Well, curl on Windows is not a very, let's say, common thing to do, but on Unix servers or Linux server, basically is the standard. So I really like, and basically from past experience, I've seen that most of our customers are using curl for data communication. You can use, of course, OpenEdge.NET HTTP library provided by Progress. I've also have a small example on how to do that, but for this session, we'll be focusing on using curl. As you can see, the post URL is that the core name / update. So we have global search update node, and I've used the path provided, the XML path provided what we generated early. You can see I do a curl request, a post request with a binary data specifying the path of the XML file, and get the response in a variable. It's basically simple stuff. I left some messages here. Then just execute the command, and basically at the end I delete the files. So simple stuff, should work. Okay, so this is for updating your data, but it's important to understand that one of the drawbacks of using Solar is that you have to keep the data updated at all times. That can be costly. So basically, you do a trade-off. You offload the querying of your database. That might be 90% of the time you will be only querying the database via Progress queries, and that can hinder performance. But you have to keep the data. You have to keep the data updated. So in a production-like environment, this is not, let's say, a best practice to do it. Basically, what I would recommend is create a table. On that table, create, let's say, unique keys with the keys that have to be updated, and then query your database, create the XML files, and then post it. Why to do that? You will be having a background processing to do that. That background processing can be maintained. Basically, you have to be able to stop it, pause it, because of your production needs, and so on. So that will be my recommendation when doing something like this in production. Okay. Here is just a simple you update the record and you update the Solar DB with that newly record. But think like in production, you don't want for the user to stay or to wait for your update of the Solar DB. So that's why you have to decouple these two processes and use something like a background process, or I don't know, something from Linux to do that offloading. And of course, the nice part is that you can pause it if you want to. So basically, this is about update. I don't know if there are any questions so far. All clear? Yes, please.
I have just one.
Yes.
In the XML schema that you showed us, it was important to fill in the text field.
Yes.
Because that was the searchable field.
Exactly.
What if I want to use multiple fields? Let's say it's in your example it was a customer.
Yeah.
It may have an address, it may have a customer ID that I know
Yeah.
besides the customer name. Can I add multiple keys so that it actually points to the same search index?
Well, the Solar permits you one unique key. That's the ID. That's the only requirement that it has. The other things you can define your multiple fields and you can fill that. And basically, what you can do, it's querying query on that field. Basically, what I wanted to show you here, it's querying on a text field, but filtering on the entity that can be customer or order. So you have the possibility to search on that, but we will get to that later in the presentation, okay? Okay, so this is about dataset definition, and I said here what we discussed about posting data, how can we post data, you will see here, and the commit stuff. And basically, we are in the point, okay, I committed all my data, the data is updated in Solar, what do I do with it now? Where I use it? One of the business cases for a customer that we had is that the customer has, how to call it, a call center when customers are calling to find data about their contracts, about their orders, what is their order status, and things like that. And what happens is that it's really hard for a call center operator to have multiple screens open and quickly identify a customer. So what we did for them is having a unique field on top of the application. You enter the phone number, you enter, I don't know, something that is known by the customer, and you will get the data for the customer. How do we do that? Is with Solar. Why? Because you cannot search for, let's say, multiple databases only knowing, for example, the VAT number or something like that of a customer. You have we have to search through dozens of tables at once. Basically, this is what Solar does. And what we see here is actually the query. And you will see here that the filter query is on entity and the query is on text. That's what I wanted to pinpoint, is that you will have you have this possibility. It's a very simple query. Doing a query like this in Solar can be much more complex than this. You have a lot of options here. So I will not discuss you with this. This requires, let's say, special knowledge, and you have to get that knowledge from researching. One important thing is that you can select the output format. So it can be JSON, XML, CSV, and so on. And basically, this is how the data will be presented back to you in an XML format or JSON. For this, we can use like a JSON. And you can then start querying your database. Basically, on the schema, I can, let's say, search for an ID, and on low term info, I can do it like this, and you will see here the query generated and how the data is returned it back. It's very simple, but just to know that this is basically what Solar will return you back, and you will see the ID, the entity. Of course, customer does not have a parent ID because it's on the top of the list. If we will be querying an order, then we will see there a customer ID, and we can query basically everything like this. So, any other questions so far? I will show you more ways and something in OpenEdge also to query the DB. Okay. So, for querying the data in OpenEdge, I'm using again not something standard. I've used vget application. I don't know if you heard about it. So it's simple to get the data with vget. I've shown you at the beginning. That is how we downloaded the tar file to install Solar. Again, installing on Windows, it's a little bit tricky, but it will do. What I want to show you here is that I've constructed, hard-coded the query, basically text and entity are hard-coded. You will see filter query equals entity, query equals text. This is not production standard. You will have to have that in parameters or something. You need to be able to, let's say, to have some leverage on how to do that in production. And basically what I do is execute the query, and I will just instructing to write that to a file via output document option of the vget, and then just read in the file. Okay, I think I have a Solar search. Yeah, I can show you how it works. You will see here that I put just a message just to see how is the command, and where it will put the data, and then with the message you will see here what it has found. It found 43 records. There are more there, but basically this is what it returned it. So there are 43 customers that have name John. Another trick here is to have a weight in the Solar database, like a way field or something like that. So if it's a name, to know to go to the customer. If it's you call it via VAT number, to know that this is a VAT number or something like that, and attribute a more weight to that number. Another trick that I've seen in production is to use a prefix when you index fields from your DB. Like if you index telephone number, you put a T in front of it, you index it with a T. And if you put a VAT ID or something like that, you index it with something else. And you will instruct the customers or the users to use that prefix to search for the data. Because then a number is very common. You have postal codes, you have all sort of numbers. But if you want for the user to, okay, now I'm searching for a telephone, then you will put a T and the telephone number, and then it will go much faster for them to do that. So basically, this is how you speed up things even more when doing querying. Again, these are two technologies that usually resides on the same server. So you have to be aware of monitoring. You have to be aware that your Solr server has to be up and running at all the time when you're querying and update. So it's something that you have to take into consideration when you're implementing this. There is also, let's say, not a problem, but you have to be careful of the memory used by this process, because this is a Java process. If it, let's say, you load more data to it, it might crash. So monitoring, it's something that it's advisable to do for the process. It's not in the scope of the presentation, but I thought to bring it up to you. So this is what we show so far. Also, you can play around, let's say, querying the data. Also, here I've put an Postman example. Why? Because here you can define your parameters. You can play with it before developing. You want to be able to know how to construct a query. So basically, here once you check on something, it will show you how to do the command. And the funny thing about this Postman is that it can also provide you with the curl command associated with it, so you can run it directly on the Linux machine. And this is basically the wget command that I've shown you. And I wanted to show you today also using the OpenEdge.NET HTTP library. It does not work on localhost. It works on any other URL address from the internet, but not on the localhost. I did not want to debug it. So I know that the code works, but does not work on localhost. So let's leave it like that. And I'm almost at the end. This is two references from where I did some inspiration from. Basically, one of them is how to install on VSL to the Java stuff that you need, and the other one is how to install Solr in 5 minutes. But basically, that's how it takes to load your schema and let's say start your server like 5 minutes. Querying and updating from OpenEdge, that's another stuff. And basically, that's what I wanted to show you today. Any other questions so far? Please.
Were there other solutions you tried before trying Solr? Because I would think about another table that would mimic the Solr thing with a word index on it. That you could
Yes.
Or does that fail somewhere?
No, basically, we didn't want it to use word indexes. It's not a bad, let's say we tried to use it and it was not a good practice to have word indexes. Basically, the size of your DB can increase drastically with that. So we tried search for alternatives with word indexes is something, but basically on a production database, you want to keep the database as simple as possible. Adding a word index on a database is not keeping things simple. So basically, we want to offload totally from the OpenEdge landscape this performance issue. And this was one of the solutions. Please.
Did you compare Solr to Elasticsearch?
No. Solr, let's say we use an old version and it's there and it's doing quite okay things in production, so we wanted to keep it like that. And of course, Elasticsearch sounds nice, but for now we are not trying to improve the solution. It's let's say good enough for the production environment that we have.
I think the code will be available for everyone.
Yes, the presentation and the code and all my notes related to the presentation will be available.
Do you install solver on the same server as your database? Or
Yes.
Absolutely.
Yes. That's why I said that you need.
Everything's on the same.
Yeah, I didn't want to discuss security and stuff like that. It's all on the same server. However, you have to monitor it. So the Java memory size, it's a problem from time to time when you do heavy updates on the DB. So that's your main point. And as a best practice, we only do it via one PID. So only one process can update. So we always keep a PID lock on that process. And we have a daemon running, and it will always check that it's someone else posting on Solar. Just, let's say, to not hinder the server performance, because that's a DB server. So all the resources should be allocated to the DB, not to the, let's say, auxiliary processes.
Did you compare using word indexes
No.
with a load that Solar
No.
creates?
No. As I said, we stayed away from word indexes because we don't consider it as a simple solution for an OpenEdge database.
It might be a problem if you have a production
Exactly.
database in one.
Yeah.
You want to keep your database stable, you know,
Exactly.
otherwise it's being used a lot.
Any other things? Maybe I will improve the, let's say, the presentation with some performance benchmark, but I wanted just to show you how simple it is to, let's say, to have a bridge between Solar and an OpenEdge DB. Thank you. Making the code available, it's simple code. In production, it's not that simple. We are having a structured OERA approach with classes and so on. So we'll have your base entity class. You will have each entity have its own class. As I said, you have a daemon running, checking for the PID lock, updating only once, and so on. These are things that take into consideration when you're doing this in production. So just keep in mind that things can be complex.